conclusion after a lifetime of research.
He did.
Yeah.
It basically challenges the bedrock of how we viewed the physical world for centuries.
And the quote that just grabs you, the one we're kind of using as our mission statement today, is Dürr saying, "Matter is not made out of matter."
It stops you in your tracks, doesn't it?
It really does. And he elaborated later saying, "The main result was actually there from the beginning, but I did not really believe it, that matter doesn't exist. And then at the end, I realized it did not exist."
You can almost hear the weight of that realization. Decades of work leading to it's not there.
Exactly. So that's our deep dive today. Unpacking this, what does it mean scientifically? What are the philosophical roots? Because this isn't just tweaking a formula.
No, it's a revolution in worldview. It suggests reality is fundamentally, dynamic, relational, not made of tiny solid things.
And if that's true, if the base layer of reality isn't fixed, solid stuff, but this realm of potential, think about what that means for limitations, for what you think is possible. The idea of a set future just dissolves.
It really opens things up. And Dürr's insight didn't come out of nowhere. It's really the combination of physics in the 20th century wrestling with, itself.
Wrestling with the old picture, the Newtonian one.
Precisely. The Descartes-Newton model gave us this clockwork universe. Everything's made of separate, inert little particles. Predictable, solid.
Yeah, the common sense view, almost.
Right. But Dürr argues quantum mechanics just completely dismantle that. It doesn't hold up.
So he needed new language. And this is where those German terms come in, right? To differentiate the old view from the new.
Yes. He used reality for that classical mechanistic world, the world of separate objects we perceive, the stuff that feels solid.
Okay, Realität is the world of things, the snapshot.
The snapshot, exactly, what you see. But he contrasted that with something deeper, something primary. Wirklichkeit.
Which translates to?
Realness or actionality is close. It's the underlying, holistic, dynamic, interconnected source of everything. Its potential in action.
So Realität is like the tip of the iceberg, and Wirklichkeit is the huge hidden mass underneath, the process.
That's a great way to put it. Wirklichkeit is the river. Realität is just the momentary pattern on the surface, the coarsened average, as he put it. It's the effect, not the ultimate cause.
Which means the solid reality we interact with is just a temporary manifestation of this deeper potential.
Exactly. What feels like a hard limit is just a stable pattern emerging from this incredibly dynamic open base.
Okay, let's unpack that. If matter isn't matter, what are atoms then? What's this table made of, if not stuff?
Well, Dürr's view is quite elegant, really. He says atoms are basically concentrations of invisible energy.
Invisible energy.
Yeah. What we perceive as solidity, density, localization. That's just what happens when the vibration of this energy slows down or stabilizes to a level our senses can pick up.
So our senses are tuned to a specific frequency range, and we mistake that stable energy pattern for a solid object.
They're pretty much. We're tricked by the stability. It's like seeing a very stable whirlpool in a river and thinking it's a solid pillar. The form is consistent, but the underlying nature is pure flow, pure energy.
So a physical barrier, say, isn't an absolute thing blocking you, but more like a very persistent energy pattern.
A very stable configuration, yeah. A pattern held together by probabilities and relationships within this vast unseen network.
And this wasn't just theory for him, right? His own experimental work pointed this way.
It did. He spent like 50 years, along with many others, searching for the ultimate particle, the smallest indivisible bit of matter.
The fundamental building block.
Right. And he concluded that search was fundamentally flawed.
How so?
Because that basic component, that tiny independent thing, simply doesn't exist as a thing.
Yeah.
The whole search was based on a faulty assumption that reality is built from nouns.
Sensitive verbs.
Exactly.
Yeah.
The universe deals in verbs, in processes, in happenings, not static nouns.
So if it's not substance, what's the replacement? What's the verb?
Dürr proposed a relational and process-based ontology. What's fundamentally real is the dynamic web of connections, of relationships. Physics isn't about stuff, it's about structure and process.
And he had a name for the elements in this web, didn't he? Moving beyond particle.
He did. He introduced the works. A work isn't a thing you can hold. It's more like a unit of becoming, a relationship in action, an event.
Like a happening, an act.
Yeah, haps is a good way to think of it. Fundamental events. Reality is defined by what happens, not what is in a fixed state. It's a profound shift from being to becoming.
It makes the universe feel much more alive, less mechanical. But
Okay.
is this just philosophy tacked onto physics? Do the experiments demand this view?
Dürr argued they absolutely do. The experimental results, especially in quantum mechanics, point directly away from independent things. And this led him to see connections with much older ideas.
Like Eastern philosophy.
Exactly. He found that concepts from Indian non-dualism, specifically Advaita Vedanta, actually offered a better language for quantum reality than traditional Western thought.
How so? What's the connection?
Well, Advaita's core idea is non-duality, Advaita, meaning that underneath it all, there's only one reality. Separation is an illusion. Dürr saw his Wirklichkeit, this undivided quantum potential, as a scientific reflection of that.
And the world we see, the separate objects, the realities.
That's the illusion Maya in Advaita, the scientific picture Dürr painted, where the material world is a temporary pattern emerging from a deeper, formless potential. It just resonated perfectly with Maya.
So the separation we feel between us and the world, or between objects, that's part of the illusion.
According to this view, yes. It's a product of the manifestation, the Realität, not the fundamental nature of things, the Wirklichkeit, which means perceived limits aren't ultimate laws, they're part of the temporary show.
Okay, so this isn't just Dürr's philosophical flight of fancy. You're saying there's hard science behind this idea of reality being relationships and potential, not stuff.
Absolutely. This brings us to quantum field theory, QFT. It's arguably our most successful, most tested physical theory ever. And its fundamental premise backs up Dürr completely.
QFT is the engine driving this, then?
It really is. It provides the rigorous scientific framework. QFT forces us, scientifically, to abandon that old picture of particles as tiny billiard balls.
So if not particles, what's the foundation according to QFT?
Fields. Pervasive quantum fields filling all of space and time. That's the bedrock.
Fields, like magnetic fields?
Sort of, but more fundamental. Think of a field as a property that exists everywhere. And particles, electrons, photons, quarks, all of them are just localized vibrations or excitations of these fields.
Ah, so the particle isn't the thing, the field is. The particle is just the field getting excited in a specific spot.
Exactly. Sean Carroll put it bluntly. Everything is fields. There is no such thing as particles. That's the QFT message.
Why did physics have to go this way? Why fields?
It came down to Einstein, really. Special relativity. Early quantum mechanics worked fine for slow stuff, but it broke down near the speed of light.
Right, relativity messes with things.
It does. To get a quantum theory that respected relativity, you had to use fields. A field exists everywhere, so it handles relativistic effects properly. Particles are just localized bundles of the field's energy.
Can you give an example where the field view just worked better?
Oh, definitely. Paul Dirac's equation for the electron, he tried to make a relativistic quantum equation for it.
Yeah.
His equation worked brilliantly, but it predicted something weird. Particles with negative energy, which didn't make sense initially.
In negative energy, like less than nothing.
Sort of. The only way to make sense of it was to realize Dirac wasn't describing just an electron particle. He was describing an electron field. And that field could be excited in two ways, creating an electron, positive energy excitation, or filling a hole in the negative energy C, which looked like a particle with positive energy and opposite charge.
The positron, the antiparticle.
Exactly. The equation naturally predicted antimatter because it was describing the field. The later discovery of the positron was a massive win for QFT. It showed the field is more fundamental.
So particles are just ripples on the field, temporary manifestations.
That's a perfect analogy. Ripples on a pond. The field is the water, the persistent medium, and QFT is the language used for the standard model of particle physics.
Which describes all the particles and forces we know, pretty much?
All the fundamental ones, yeah, quarks, leptons, the force carriers like photons. It's all QFT, even the Higgs boson discovery in 2012.
That wasn't finding a tiny particle.
Not really. It was confirming the existence of the pervasive Higgs field that permeates all of space and gives other particles mass through interaction. Again, the field is primary.
Okay, let's talk about the vacuum. Dürr mentioned the universe emerging from nothingness or emptiness. QFT seems to agree the vacuum isn't empty.
Not even close to empty. The classical idea of a void is dead. In QFT, the vacuum is just the lowest energy state of all these quantum fields.
Lowest energy, but not zero energy.
Not zero, and definitely not quiet, because of Heisenberg's uncertainty principle.
Can't know everything precisely at once.
Right. You can't know the energy of a system perfectly over a tiny time interval. This allows the vacuum to constantly borrow energy for brief moments.
And what does it do with that borrowed energy?
It creates virtual particle-antiparticle pairs. They pop into existence out of the field fluctuations and then annihilate each other almost instantly.
Constantly, everywhere.
Constantly, everywhere. It's a sea of phoning, fleeting potential. These aren't real stable particles, but they are real effects of the underlying fields buzzing.
That sounds incredibly chaotic. How do we get stability out of that?
Well, it's not just chaos, it's structured. The vacuum has this zero-point energy. Dürr saw this dynamic energetic vacuum as the Wirklichkeit, the ultimate ground, the source from which stable real particles emerge as sustained excitations. His emptiness is actually a plenum of potential.
Okay, but that sounds very theoretical. Is there actual proof this quantum foam exists and does things?
Oh yes, the Casimir effect, predicted in the 40s, measured later.
What is it?
If you take two perfectly smooth, uncharged metal plates and put them incredibly close together in a vacuum,
Yeah.
they attract each other. A tiny but measurable force pushes them together.
Why would they attract? There's nothing there, supposedly.
But the QFT vacuum is there. Outside the plates, virtual particles of all wavelengths can pop into existence. But the tiny gap between the plates restricts the wavelengths that can fit inside.
Like resonance in a cavity.
Exactly. Fewer possible virtual particles inside means less vacuum pressure inside compared to outside. So the pressure from the virtual particles outside pushes the plates together.
Wow. So we can measure the force of these virtual particles.
We can. And it proves the vacuum isn't empty. It's a dynamic, energetic medium. It's the source. This gives real experimental teeth to Dürr's idea that reality is grounded in this active, non-material potential.
So the science of QFT, especially the active vacuum, naturally leads us to this idea of potential. Dürr called it potentiality, right? And this comes directly from Heisenberg.
It does. Heisenberg was really grappling with the meaning of the quantum wave function. It clearly wasn't describing a little particle flying around before you measured it.
Because the particle didn't have a definite position then.
Exactly. But it wasn't just subjective ignorance either, not just our lack of knowledge. It seemed to describe something objectively real, but not actual.
Something in between.
Something in between. So Heisenberg revived a concept from Aristotle dynamis, meaning potential or capacity, and called it potentia.
Okay, but how is this objective potentia different from me saying, it's possible I might win the lottery? That just reflects my uncertainty.
That's the crucial point. Your lottery odds reflect subjective ignorance. Heisenberg's potentia and Dürr's potentiality is an objective feature of the quantum system itself. It's real. It exists before measurement.
But it's not matter, not energy.
It's not actualized matter or energy. Dürr said it's just in the middle between possibility and reality. It carries information, probabilities, relational structures, but it's not a thing yet.
So the universe, at its base, is made of this field of objective, unrealized potential.
That's the picture. And this potential gets actualized. It becomes concrete, measurable reality only through interaction, through measurement.
So this reframes the whole weirdness around quantum measurement. The wave function collapsed.
Completely. Instead of a mysterious physical collapse of something material, measurement is seen as the moment of creation. It's the process where the non-material potentiality becomes actual.
The Wirklichkeit gives birth to reality.
Precisely. The interaction selects one possibility out of the potential field and makes it real. The resulting particle or event is the outcome of this creative act within the quantum realm.
Which means limitations aren't fundamental brick walls, they're just the patterns that have become actualized so far.
Exactly. The potential is always deeper and broader than the actuality.
This focus on process, on becoming, really puts Dürr in line with process philosophers, doesn't it? Like Whitehead.
Very much so.
Yeah.
Dürr rejected the universe as a clock idea. For him, reality wasn't a collection of static things, but an ongoing series of creative events, his works or haps.
These fundamental happenings.
Yes, acts of integration where potential takes form. He insisted the universe is an open world of genuine creativity, constantly actualizing itself, constantly becoming, not just running down according to fixed laws.
And the logic of this deeper potential reality must be different too, not the simple A or B logic.
It has to be. Classical logic is either or entweder oder. A particle is either here or there. But the quantum Wirklichkeit, the realm of potential, operates on both ends, so the all's almas. Before measurement, the system holds multiple potentialities simultaneously. It's in a superposition of states. This multiple-valued logic reflects that undivided network of possibilities. The potential is richer than any single outcome.
Okay, so we've moved from matter to fields, from fields to potential. Dürr then takes another step, linking this potentiality to something, well, more spiritual.
Well, he does. It's maybe his most radical step.
Yep.
He equates the underlying immaterial connectedness, the Wirklichkeit, this fabric of potential and relations, with spirit.
Spirit, as in consciousness or something like that.
He explicitly said matter derives from spirit. And he went further, equating this spirit with love, or maybe embryonic love, a kind of fundamental creative potential inherent in the universe.
So the very foundation of reality, the quantum potential described by physics, is, for Dürr, intrinsically creative, maybe even conscious in some sense.
That's the implication. It's not a dead, inert substrate. It's an active, generative source. This view provides a way to see how the solid world, the realitate we experience, emerges as stable patterns within this fundamentally creative relational network.
The implication being that the potentiality itself is inherently creative, and that's the base layer.
Yes, the foundation is alive with possibility.
If the universe is fundamentally about relationships and potential, then the idea that things exist separately and independently must be wrong. Which brings us to non-locality, right? This spooky action at a distance.
Exactly. Non-locality is the experimental knockout punch to the idea of separability. It's been confirmed again and again through tests of Bell's inequalities.
Remind us what that shows.
It shows that if you take two quantum particles, like photons, that are created together in an entangled state, they remain connected no matter how far apart they fly.
Connected how?
If you measure a property of one particle, say its polarization, you instantly know the polarization of the other one, even if it's light years away. Instantly. Faster than light.
Which shouldn't happen according to classical physics and relativity. Information shouldn't travel faster than light.
Precisely. It violates local realism. It proves that these particles aren't separate little things with predefined properties. They're behaving as one single undivided system.
So properties aren't inherent in the particle. They arise from the relationship.
Yeah, that's the relational view. Properties are defined by interaction and context within the whole system. Non-locality is the scientific proof of Dürr's Wirklichkeit, the underlying undivided wholeness.
Dürr wasn't alone in thinking about this wholeness, was he? David Bohm had similar ideas.
Very similar. Bohm's model of the implicate and explicate order is a powerful parallel.
How does that map onto Dürr's terms?
Bohm's implicate order is the deep, enfolded, non-local reality where everything is interconnected. It's very much like Dürr's Wirklichkeit, or the realm of potentiality. It's the hidden source.
And the explicate order.
That's the unfolded, manifest world. We perceive the world of separate objects and structures. For Bohm, this explicate order is constantly emerging from and folding back into the implicate order. He called this process the hollow movement.
So particles, for Bohm, are just
temporary patterns, ripples, abstractions unfolding from the deeper implicate whole. Both Dürr and Bohm arrive at this fundamental undividedness, though their technical details differ slightly.
What about more contemporary views, like Carlo Rovelli's relational quantum mechanics?
Rovelli also emphasizes relations, strongly rejecting substance. But RQM takes relativity perhaps even further.
How so?
For Rovelli, properties only exist relative to an interaction with another system. Any system can be an observer. There isn't necessarily one underlying objective reality like Dürr's Wirklichkeit. Reality is just the network of interactions.
So RQM is perhaps more focused on the information exchanged in interactions, less on an underlying potential field.
You could say that. Dürr maintains an objective Wirklichkeit even if it's non-material potential. Rovelli focuses more on the relative nature of observed properties. But look at the trend. Dürr, Bohm, Rovelli, they all point away from isolated things towards connection, relationship, and wholeness as fundamental.
The universe is a network, not a collection of marbles.
That's the emerging picture, yes.
What's fascinating about Dürr is how comfortable he was connecting these cutting-edge physics ideas to ancient wisdom traditions.
He really was. He didn't see a conflict. He often said lecturing on quantum mechanics felt like discussing Advaita Vedanta or Buddhist philosophy, the non-materiality, the interconnectedness. It resonated deeply.
Let's explore that Buddhist connection, the idea of emptiness, shunyata. How did Dürr see that relating to the quantum vacuum?
Well, shunyata doesn't mean nothingness in a nihilistic way. It means empty of inherent independent existence.
Ah, so things don't exist by themselves.
Exactly. They're dependently arisen. Their existence comes from their relationship to everything else. They lack intrinsic self-nature. This is precisely Dürr's point about particles not existing as independent things.
So the emptiness is an emptiness of separateness.
Yes, and Dürr saw the quantum vacuum, this boundless potential, empty of fixed forms, but the source of all forms, as a kind of scientific counterpart to shunyata. It's the fertile void from which relational reality arises.
Again, it reframes limitations. They aren't absolute, they're dependent manifestations.
Correct. And for Dürr, understanding this wasn't just an intellectual exercise. He saw profound ethical and societal implications. He believed our failure to grasp this interconnected reality was driving major world problems.
How did he connect quantum physics to, say, economics or sustainability?
He argued that the old classical materialist worldview, seeing the world as fragmented, made of separate competing things, directly fosters harmful societal structures,
Like what?
like aggressive competition, exploitation of resources seen as inert objects, zero-sum games in economics. He called this the paradigm of the dead,
Strong words. Why dead?
because it's based on a view of reality as static, separate things to be controlled and fought over, rather than a living, interconnected process we participate in. It ignores the demonstrable wholeness and relationality of the universe.
So, for Dürr, truly accepting the science, the interconnectedness revealed by quantum physics, is actually an ethical imperative.
He argued exactly that. Shifting our worldview to align with quantum reality, embracing wholeness, relationship process, is necessary for building sustainable, cooperative, and truly democratic societies.
It requires moving from a mindset of domination and separation.
To one of participation, co-creation, and dialogue within this living, evolving cosmos. Science shouldn't just be about control. It should foster wisdom and understanding of our place within the whole.
It really highlights how our underlying assumptions about reality shape the world we build. If you assume fragmentation, you build walls. If you assume connection,
You build bridges. Dürr's point is that the science itself tells us connection is fundamental. The limitations we perceive are often self-imposed, stemming from clinging to an outdated, fragmented worldview. Wirklichkeit offers a vastly more open and creative potential. Hashtag OUTRO.
wow, this has been quite the journey, from subatomic fields to the fate of the planet. Let's try and crystallize the main takeaway from this deep dive into Dürr's work. I think the core message is this. According to Dürr, backed by quantum field theory, the fundamental reality isn't made of solid, fixed stuff imposing limits. It's made of dynamic, objective potential and interconnected relationships. The universe is fundamentally open.
And the key practical distinction to hold on to is Dürr's Realität versus Wirklichkeit. The world you see, the fixed forms, the apparent constraints, that's Realität. The temporary snapshot,
But the deeper reality,
that's Wirklichkeit, the flowing, creative potential, the actionality. Your true capacity lies in engaging with that process, actualizing that potential. The universe's deepest law isn't static being, it's dynamic becoming.
so if the base layer is pure creative potential, then limits aren't absolute walls. They're more like patterns we're currently tracing within a much larger space of possibility.
Beautifully put. Which leads us to a final provocative thought, really building on Dürr's vision. Classical materialism saw consciousness as an afterthought, something that just bubbled up randomly from dead matter.
Right, mind from matter.
But Dürr, by identifying the fundamental potential, Wirklichkeit with spirit or creative love, flips that. If matter emerges from this non-material creative potential, then consciousness, or at least proto-consciousness, might be primary. The very foundation might be mind-like,
So matter from mind, in a sense.
or at least matter from a fundamentally creative, potential-rich source that isn't inert. So if the universe is fundamentally this process of creation, and we are participants who actualize potential into reality through interaction and perhaps intention, what does that really imply?
It implies our role might be much more active than we think.
Exactly. What power does conception, does intention truly have in shaping the world that appears? The question shifts from what are the fixed rules of this game to maybe how much are we actually co-creating the game itself?